Lesson number 1, Arithmetic Progression. Introduction. Students, in the previous standards, you have studied the number system, set of numbers, operations on numbers such as addition, subtraction, multiplication and division. You might have noticed some patterns in the natural numbers. For example, in the set of all positive even integers, the difference between any two consecutive even integer is 2. Like in this chapter, we are going to learn relationship between the numbers. Explanation. Consider the following list of numbers: 1, 1, 3, 5, 7, 9, and so on. 2, 1, 4, 9, 16, and so on. 3, 8, 16, 32, 64, and so on. 4, 0, 2, 4, 6, 8, and so on. 5, minus 5, minus 8, minus 11, minus 14, and so on. 6, 1 upon 1, 1 upon 2, 1 upon 3, 1 upon 4, and so on. In each of the above list of numbers, there is a specific relation between consecutive two numbers. 1. In the first list, we get every successive number by adding 2 to the previous number. 2. In the second list, the number in the first place is the square of 1. The number in the second place is square of 2. The number in the third place is the square of 3, and so on. Sequence. A sequence is a collection, list of numbers arranged in a definite order according to some definite rule. Each number in the sequence is called a term of the sequence. The number on the first position is called first term and it is denoted by T1. The number on the second position is called the second term and it is denoted by T2. In general, the number in the nth position is called the nth term and is denoted by Tn. A sequence is usually denoted by curly bracket Tn and read as sequence Tn. Sum of the first and terms of a sequence. If curly bracket Tn is a sequence, then we denote the sum of the first and terms of this sequence by Sn, where Sn is equal to T1 plus T2 plus T3 plus and so on plus Tn. Thus we see that S1 is equal to T1, S2 is equal to T1 plus T2, Sn is equal to T1 plus T2 plus T3, Sn is equal to T1 plus T2 plus T3 plus and so on Tn. From the above sequence, we see that S1 is equal to T1, S2 minus S1 is equal to T2, S3 minus S2 is equal to T3, Sn minus Sn minus 1 is equal to Tn. Therefore, Tn is equal to Sn minus Sn minus 1. Thus, if general form is given, open bracket, Sn is equal to n plus 1 upon 2, close bracket, then we can find any term of that sequence. Types of sequences. If the number of terms in the sequence is finite, then it is called a finite sequence. Otherwise, it is called an infinite sequence. We have the following main distinctions between sequences and sets. Sequences, sets. 1. The elements of a sequence are in specific order. 1. Elements are at random. 2. The terms of sequence cannot be rearranged. 2. Elements can be rearranged. 3. The same value can appear many times. 3. Any value can appear only once. Example, for each sequence find the next 4 terms. 1, 1, 2, 4, 7, 11, and so on. Answer: given list is 1, 2, 4, 7, 11, and so on. T1 is equal to 1, T2 is equal to 2, is equal to T1 plus 1. T3 is equal to 4, is equal to 2 plus 2, is equal to T2 plus 2. T4 is equal to 7, is equal to 4 plus 3, is equal to T3 plus 3. T5 is equal to 11, is equal to 7 plus 4, is equal to T4 plus 4. Therefore, Tn is equal to Tn minus 1 plus n minus 1. Similarly, T7 is equal to 16 plus 6 is equal to 22. T8 is equal to 22 plus 7 is equal to 29. 3, 20, 25, 30, 35, and so on. In finite sequence, each term is obtained by adding 5 to the preceding term. For 0, 1, 0, 1, 0, 1, and so on. Infinite sequence of alternating zeros and 1. 5, 3, 3, 3, 3, and so on. Infinite sequence, each term is obtained by adding 0 to the preceding term. 6, 2, 4, 8, 16, and so on. Infinite sequence, each term is obtained by 2 to the preceding term. If you observe the above sequences, there is a fixed relationship between any two consecutive terms, except for sequence 4. Such sequences are called progressions. Definition: a progression is a special type of sequence in which the relationship between any two consecutive terms is the same. There are 3 types of progressions, namely arithmetic progressions, geometric progression, and harmonic progression. We shall study arithmetic progression in this standard. Arithmetic progression AP. See the following sequence: 1, 1, 4, 7, 10, 13, and so on. 2, 24, 20, 16, 12,